Hi everyone, and welcome to our next episode of Quarantine Physics. Today I'm going to show you a demonstration on polarization in static electricity. So what I have here is, I took a light bulb, it's actually a black light, but a light bulb, and I just stuck it in this cup. I needed something that was spherical, and I needed a way to balance it. This was what I could find in the house, so this is what I'm going to use. So the cup is just as a base. I have a yardstick here that I'm going to balance on the spherical light bulb here. So we want to get it like this, get it to sit. And I have a balloon. So what I'm going to do is I'm going to rub the balloon on my hair, which is already a mess because I did this a few minutes ago. And then I want you to just watch what happens. So I'll come on this side. If I rub the balloon on my hair, and then bring it up to the meter stick, you can see that the meter stick starts to spin and it begins moving. And the reason that's happening is because the balloon is charged. When I rubbed it up against my hair, it charged by friction. The ruler was not charged, but when I bring a charged object close to a neutral object, we can get that neutral object to polarize. In other words, the charges kind of spread out. So that, let's imagine for a moment that the balloon ends up negatively charged. When I bring that negative balloon up close to the ruler, the electrons that are closest to that balloon are repelled because electrons repel other electrons. So they kind of push away the electrons that are closest to the balloon. And that leaves the ruler with a net positive charge in that region. And there's a slight attraction, and that's what you see causing the ruler to start spinning around. So that's polarization in a nutshell. When you bring a charged object near a neutral object, and you cause the charges in the neutral object to separate out towards the poles, that's why we call it polarization, like the north and the south pole. We're pushing the electrons farther away in this case, and bringing a concentration of positive charge closest to the balloon. The opposite would happen if the balloon was positively charged. Then the electrons would come closest to the balloon and you'd still get that attraction. It would just be for the opposite reason. So that's it.